So every one of these balls is basically a search term, and it shows you also clusters of different things. So if you click on sort of a cluster anywhere, you can see that these are search terms that are actually connected. So if you zoom out and show the topics, so what you also can see from this graph is that this all the yellow balls are sports. So the world is actually really massively searching for sports all the time, and this is a trend that we see there every day. And then we have some different categories. So that I'll talk soon about how we put the categories on there. But yeah, sports is huge every day. So you have different filtering options here. You can filter for categories or countries. And if you're, for example, interested in, I don't know, politics, you can click on the politics and then look for if you want to see like these relevant like what are people searching for at this moment, then you can explore these clusters. So in politics, you're gonna find war, you're gonna find this is Benjamin Netanyahu, so there are people in Syria googling for what is happening with in Israel and so forth. Okay, are there questions about this at this point? So this refreshes basically every 24 hours. So these are 24 hours of search
It
results.
refreshes every 30 minutes, and it takes the last 24 hours of data.
Yeah, sorry, that's what it is. Yeah. Um, so how did we do this, right? So as I said, we were taking the RSS feed from Google Search, and as maybe you can show that very quickly, Johan, how that looks like. Um, yeah. So this is not it. So RSS feed is just an XML. So you basically get just get text like this, and for every item. So in this case, this is daily search trends of AM, which is, I don't know what country that is, but they speak they write Cyrillic. So we basically embed the whole thing. So the search term and the news items that are with it, and then we use a clustering technique called UMAP to put them on the map. Um, we use the same technique, so embeddings, to give colors to the balls. So every the Armenia, thank you, Paul. So every topic has a series of keywords, and then we use then we also embed that. So the keywords that are closest to so the keyword embedding that is closest um, to this search term embedding that gets the colors. Now, what is actually embeddings? And maybe Johan can take over here because he made a presentation about this in the past. So for
Yeah.
those who don't know what embeddings are, this might be helpful.
Let's get into that. This is a presentation that I gave on Data Harvest last year and also on the Nodes conference, which is the graph database guys. Let's get into it. So what we're doing when we're embedding textual information is that we're basically trying to capture the meaning of that text in numbers. So what we're doing is that we turn like text into a vector, into a list of numbers. And we use embedding models for these things, for these vectors or arrays or whatever you want to call them. And we call them embeddings because we're embedding language into a space. And we try to preserve the semantic relations between different texts. So, okay, embeddings, like, how do we create them? How do we compare them? Well, to create these vectors, these lists of numbers, we use special models like embeddings, like embedding. The technique of embedding is also used in these big language models and stuff, but we won't get into that. You have specialized models that we train specifically to create these lists of numbers. And yeah, like what we do during the training of this model is optimize. We want to maximize similarity for positive pairs and minimize for negative. So when we're training, we have some sort of set where we know how close things are together, and we use that set to train this model. And there's different techniques to get to this set. Like we use paraphrases, similar sentences, and consecutive sentences. For negative pairs, we use random unrelated sentences. And with that data, we try to train a model. And I don't want to get into how to train your own embedding model, because that is not important to us. There is models we can use. So let's try this with like a small, older model that only does English very well. Like here we have some code, and this code is embedding with this embedding model. The sun is shining, and we get this beautiful list of floats. So we have 384 floats here, which contains the semantic meaning of the sun is shining. Well, that's awesome, of course, to get this beautiful long list, but what do we do with it? How do we compare it? Well, we can think of it as a list of numbers, or we can think of it as a coordinate or a direction in a space. So what this list of numbers can represent is a point or direction in a 384 dimensional space. And we train these models so that these vectors, these arrows in this space, with a similar direction, they are semantically similar. So why do we compare directions in this space? And why don't we measure distances? Because you could theoretically say like, okay, I have 2 points in this space. Why don't we use distance between these points as a measure? Well, that's because of the curse of high dimensions. Everything in a high dimensional space becomes averagely closer together, or as close together as the rest. Mostly because you average out over the bigger amount of dimensions. So things will be far away in one dimension, close together in others, and you just end up with an average. You can see it here. This is plotted in this presentation actually. So you can see that with 500 dimensions, most things are averagely close together, and that the less dimensions you have, the more wide your spread there is in distance. So most of the times we compare vectors by angles. So we check in this space how small or big is the angle between these arrows in this space. So let's see what it looks like. We have 384 dimensions. Let's not do that. Let's go with 2 dimensions so we can easily visualize that. Well, we have one vector in a 2-dimensional space, another vector in a 2-dimensional space. We have an angle, and this is our cosine similarity function, and we get a certain number. So we can now say with a certain number how similar these things are. So we reduce text to a mathematical construct that we can use to say something about similarity. So let's get back to the sun is shining. Here you can see the cosine similarity scores for these other texts compared to the sun is shining. And as you can see, some things are quite similar, others are not. So that's my little talk about embeddings.
Thank you.
Sorry, is it real numbers? Sorry, I wanted to ask. On the last slide, was it real numbers or it's just example?
So that was real numbers, yeah.
Okay, it's just a very nice example because usually they're much closer, like all of them.
Yeah. It was not the first example I thought of.
Cool. Are there any questions here or comments? So this is what embeddings are, right? So that's how we are able to get this topic and its news items and put it into like this space, because Johan was showing this putting it into dimensional space. What we are doing is we are putting in 3 dimensions in this case.
Well, we're putting them in 1,000 dimensions actually, and we're reducing them down to 3 dimensions.
Yeah.
This is the UMAP reduction. We can get into that now if you want, or did you want to say something else, Ada?
No, I would like to know if people have questions. And, yeah, Paul.
Hello, I'm Paul. I'm one of I'm a former student of the Frosch, and I guess my major question is that does exploring it spatially allow you to let's say uncover more angles and more relationships as opposed to just going through trending search terms, you know, internationally? I mean, one application I thought of for it is like the relationship between these and trending bets on prediction markets, which I know is a very like vogue trending kind of topic in itself. But yeah, I just wonder, what do you both envision as the applications for this, and also how long do you plan to kind of maintain it as well, because you're hosting it, right?
Yeah, so I mean, this thing is quite, it's an experiment. So the uses that I saw here is like basically when I now get up in the morning, I don't really open like a news website. I just open this graph and then I look into it and I see where the clusters are. So I filter it. I filter out the sports because I don't really care about the sports. And I filter out into politics and business and tech and science. And then I browse through it, you know, and it's, of course it's not perfect, but it will show me like this is, you see those lines that are very white there. That means they're clusters. So that means that something is happening. And what it also allows me is to see the world happening through a different lens. I don't see it through a lens of a news editor. I see it through a lens of what people search for, which is, of course, it has its own problems, right? But it's a different entrance into what is like moving in people's lives. And of course, it has problems. Not every country has the same amount of exposure to the internet and so forth. But it's just in that sense, to me, it's interesting to see, for example, that in Egypt they're continuously searching for gold. You know, like stuff like this. Like you get to see different things. Now, if this helps you discovering new angles to whatever, I think it really depends on what you're searching for. So yeah, I don't know. Does that answer your question, or you want to
I
add
have
something,
something
Johan?
to add. Yeah, like first of all, like this whole example to me is more really like a demo to show the technology. Because I'm also looking into doing this with the evidence domain. So, for example, I have a shit ton of documents from the PFAS investigation here in Europe. I parsed all that. It's all beautiful markdown now, and that is also something that I can show in this visualization. So when I was playing around with this technique a while ago, and then Ada pulled this trends data set out of thin air, and I was like, wow, that's cool. And what I like about this and what I didn't expect at the start is, I don't know if I can find like an example here real quick. Like, no, yeah, sure, here. Like we are automatically translating all these little trend things. So we have this like translation model also on the background, or not one, like 46 translation models on the background. And we were translating all this stuff. And when Iran was going crazy with this street of horror, or I don't know the name of the street, but when this was going down, You could see news cluster that also came from Iran and other countries and languages that I don't speak at all. And to see the different angles that people take describing certain worldwide happenings and still have all these things clustered together. That is really interesting to me, to break out of my own Western bubble. But as I said, this I saw mostly as a demo of the technology. I think for journalism specifically, this technique can be incredibly powerful to make sense of huge sets of documents. And that is part of the reason why I'm looking into this.
Yeah, and having like, imagine you have a collection of documents and you can visualize it like this, like it becomes way nicer as way nicer way of exploring these documents than like keyword search. I mean, it all has its space, but this is just a additional potential technique that you can use in order to make sense of your data. Guillaume?
Hello. Yes, sorry, I was a bit late to the meeting, so I'm still processing a bit like live, but I roughly understand the system, I guess, and that's why I'm also asking, like, from a editor point of view, that would be like the tool you want, right? To come and tell your reporters, okay, this is the topic we want to report about or something. Like, do you want to go down that path and like propose it to newsrooms as well? Is like, or I don't.
You mean this particular tool?
Yes.
I haven't really thought about it. Maybe I could send some cold emails out. It's like, hey, look at my tool. My tool is amazing.
Now I was thinking about, like, so I'm focusing on agriculture topics and so on, and that would be like a perfect tool for me to cover a lot of different sources and say, okay, these published that and that and that and that and that, and to see like what are the big topics at the moment in this particular field. Like, would it be useful to do it?
Yeah, I mean, this is really like, this is online, so you can just access it. It's trends.datafrosch.fun. I can paste it here. I should have pasted it in the beginning, sorry. Yeah, it's oops. Sorry, I don't know what I wanted to say.
To ask a question, Guillaume, like, do you mean like this particular data set, so the Google Trends stuff, or do you mean your own data, right?
Or yeah, I guess you can feed it with like whatever data you have or something.
Yeah, there is like two big parameters that I'll get into later. Two kind of like sliders that you have to play with when you make a graph like this. But this particular code we will probably open source. Like I spent some time on this just for data harvest, honestly. So this repo will go out, or Ada has all kinds of monetization plans that I don't know about. But this will probably just go out open source, and I will probably share a link on data harvest by the time, or maybe before, even if I have something before that, I can just send you a message.
Yeah. So, yeah, I mean, how to make this in a way that it's your own data. That's like, it's not that straightforward, right? But and this data set has its limitations as well. As I said, this is like Google search trends, so I can imagine you can plug it to different data sets that are more relevant for you, especially if we're like, for example, RSS feeds of agricultural publications, of all sorts, maybe. Yeah, but this will anyway be open sourced, this tool. So
I will probably take out this visualization aspect as a little library that you can use, because I'm going to use this exact same visualization for the evidence domain of the PFAS stuff. So this will probably be a nice little library that you can use.
Yeah. Yeah, maybe we could talk a little bit about UMAP and what UMAP actually is, because like one thing is having these embeddings, but as Johan was saying, these embeddings, they have thousands of dimensions, and we are just distilling it to 3. And maybe we don't have to go like super deep into this, but yeah, there's this very nice explainer on what UMAP is, and it's basically dimension reduction algorithm that allows you to there are many dimension reduction algorithms out there. UMAP is a relatively new one, I think, and widely used now. So if you do any clustering these days, and maybe Anastasia has something else to say about this, but this is what we used as well to kind of reduce the dimensions. And how does it exactly choose which dots are then close together in this case? It's not super clear, at least to me.
I can say a couple of things about it if you want.
Yeah.
I shared this page because they have a wonderful example. They reduce this three-dimensional mammoth into 2 dimensions, and they give you the 2 big sliders that I was talking about before that you can tune in this algorithm. So what UMAP does is it takes the original distances from the original dimensions you have, and it constructs some sort of meta graph. So it creates a weighted graph with weighted edges on how close things are together. And then in this lower dimensional space, it takes this graph that it created and recreates, basically with the original distances, it recreates a graph that works. So UMAP first, for every point, it takes an amount of neighbors, and it looks at the minimum distance it wants to visualize for or project for, and based on these 2 sliders, it recreates a lower dimensional projection. So that's why this mammoth is nice, because you can really see this this mammoth here. You can really see it, yeah, be projected, which is kind of like a nice intuitive example, I would say. So there is way more to it. There is serious math behind all this that is also out of my comfort zone. Yeah, this is what I have to say about that.
Thank you. Yeah. Yeah, in terms of other tech that we use, like Anastasia, you were asking about the models. We use BGEM3 because that was recommended to me as the best one for multi-language use. So when you are doing embeddings, you really need to make sure that you are using the right model, because some are good for some languages, and some perform good for multiple languages. Yeah, there's even a leaderboard for that at Hugging Face. If you don't know Hugging Face and you're interested into models, check it out. It's a really wonderful project. And another thing that we're doing, as Johan was showing, that we are translating. And so what we basically wanted to do with this tool, as you asked Paul, like, how long is this going to be up? Because we're hosting it, like the hosting part is not that big of an issue, but what is an issue is that if you have to call a API, to do any embeddings for you or any translations, as we're doing, because that costs money, right? Every API call costs money. So we're using this embedding tool because it's a local model. So we have that model on the server, and next to that we have this Argos Translate library there that also uses language that uses local models for language translation. We don't have all the languages, but we have many of them. So you also won't see everything translated on the tool, but most of it is. And this is just two libraries running on the server. So we basically are not spending any money running
for
this.
reference, this is really running on like a €5 Hetzner VM, like a little ARM box. It will run on your phone. It's very lightweight.
Yeah. And that's another reason why I think this project is really cool, because you basically can run it on like €5 Hetzner VM, and you don't have any other costs associated with it, which I found, which I also think is what journalists are always looking for, these solutions that don't cost money. So there is one. This is one. Yeah, Paul.
Sorry for kind of filling your time with questions. Thank you. That's really helpful. I just wondered what was the explanation for the limitation of the frequency, because I can see this also as a fantastic visualization for understanding Google Trends kind of in real time. Is that just a limitation of the RSS, that dependency, or
not really? UMAP is a quick algorithm, but it's a quick algorithm in projection algorithms land. So taking all these points and running this projection takes a couple minutes. Like it's I don't know if there's real-time versions out there, but I don't think this is something.
I think that's the RSS feed of the Google Trends. It refreshes roughly every 10 to 15 minutes. So it's also not super real time. The ones that we use, yeah. So yeah, and then we take 30 minutes to pull in new things, and yeah.
But so it's not 24 hours, right? It's 30 minutes.
No, it's 20. It's we aggregate it over 24 hours.
Right.
So if there is a trend that after 24 hours disappears, like for example, you have the same trend but with different news sources.
Mm-hmm.
So we kind of replace that every time there's the same trend and it has new sources. And once the trend disappears, it disappears from our. Once the trend disappears, if in 24 hours it's not there, it disappears from our visualization as well. So it's not it's aggregated over 24 hours, and then items older than 24 hours go.
Awesome.
Is that clear?
Yeah, thank you. That's really helpful. I've actually got a data set that would be like a really, really good fit for this. That's also quite regularly updated, but actually less regularly updated than yours.
Yeah.
Is the Google transparency reports.
Yeah.
In
terms of the takedown notices of
yeah.
Yeah, that's also cool. Data set. They basically publish who asks for being taken down from Google results.
Yeah, like all of the MCA.
All the DMCA.
Yeah, you might find very interesting clusters in there.
Yeah,
for
totally.
people who are interested in like reputation management, or one might say reputation laundering companies, then something like the visualization that you came up with would really, really help seeing those clusters kind of pop out in real time.
This reminds me, talking about clustering reminds me of something which I would like to show you. Like what we do here with these pretty colors is that we have, we don't really use actual clustering here. For every point in this space, we calculate the distance to the embeddings that we have for these concepts. So if you think of politics, for politics, we have a list of words that all sound very political, you know? So we have like conservative and progressive and all of that kind of nonsense. We have a ton of words. We embed those all together, and that gives us sort of like an anchor point in this high dimensional space. And for all these points, we kind of track like how close they are to all our different anchor points. So we don't do actual clustering here. But you can do clustering. There is things like HDBSCAN, and there's more more clustering algorithms, you can do clustering over this original high-dimensional space, which allows you to detect things that are close together in this high-dimensional space. Because what can happen when you reduce these things down is that things that are very close together in this high-dimensional space end up quite far apart in this projection. So what you see here is like we have all these white lines, and these white lines they show the more clear this white line shows, the more close together these things were in their original space. And you can see that lots of these things end up also close together in our projection. But not all of them. There is here 2 of these stories that are very close together. They're both about David Hasselhoff, which is like
Slovakia is really into David
biggest Slovakia.
Hasselhoff.
Yeah. Anyway, like you can use these HDBSCAN clustering algorithms, for example, to end up with automated cluster detection for your high-dimensional space, and that allows you also to, for example, give pretty colors to things depending on which clusters they share. So I wanted to kind of get in or mention that at least that you can also cluster over this original space.
Yeah, and like in terms of like practical, if you want to adapt it to your use case, once that we publish this, it probably we can already publish it, no, Johan?
Yeah, I'm gonna clean it up a bit, but
yeah.
Yeah.
Then you can basically then talk to Claude and say, okay, I have this tool. I have this. This is the tool. This is the data. Help me fix my data onto this visualization. So that would be a way how to proceed adapting it to your needs if you wanted to. Oh. Sarah?
Maybe just summarizing or clarifying question from my side. So for the retrieval and the categorization of the data, you used the BGE M3, and then the clustering came after with the UMAP. Was that kind of the process?
Yeah, exactly. First we fetch all this RSS, then we take every item on that RSS stuff. We take the keyword and the titles of the articles. Those together we embed with this BGE model. These embeddings we store. Then we use these embeddings to calculate how close these things are to each of these categories basically. And those scores we also store. So here you can see all these, like how close is this closest to entertainment and to disasters. So we save that. The original text of these news items that is there in the RSS, those we translate with those Argos models, and those translations we also store. And then when that is everything we do with these specific little RSS items. And then once every half an hour or so, we take all these embeddings we have of all these things, and we ram those all into this UMAP projection. So in UMAP, this projection also we store, and that is what we send to the browser in the end. Does that answer your question?
Yes, totally. Maybe just briefly to follow up on that is the labeling, like the ones that you have there in the topic distribution, did that come already from the data set in some way, or did the model kind of unsupervised way identify these categories and topics, or was that something labeled by Google or labeled by you in some way?
These are chosen by Ada, and the words that are used to embed these concepts, those were chosen by our friendly neighborhood chatbot, Claude. And
this is partially true because some of these topics, they actually come from Google Trends themselves. So Google Trends, I think they identify, because they also have an API next to this RSS feed, they identify about 21 topics. But the 21 topics is way too much. So I've chosen a couple, and already what we see here is that, for example, the topic disaster is a bit unfortunate because all the weather is now categorized as disaster, which is, I mean, sure, it depends on where you look at it, but it's not always about disaster. And also, like, for example, there was this one TV show that had very bad, like, that ended up as a disaster after its initial screening, and that was also categorized as disaster in here. So already the topic disaster is a bit problematic here. So I think we can do it better. That's basically the point.
Yeah, I would like to add to that is that using these anchor points like we're doing here, we show it as something is really politics, but as you can see, something is like a bit politics and it's a bit disasterish also, and it's a bit sportsy. So it's not really a way to do real categorization, I would say. It's more a way to give some form of vibe in which direction the story is. But it doesn't really put like a solid topic on there. Jacob?
Yeah, so I was just wondering how slim could you go here? Because I mean, especially in my field, which is like hockey, and I played around with the graph a bit and noticed that okay, there's a really hard line to understand what kind of sport it is, because a lot of teams all over the world, for example, shares at least one name. And so on. So I wondered how slim can you go in the fact that, okay, I want to look at hockey in certain areas of the world, and also can you add more sources in the clustering of all these keywords? Like if you would look upon like a tool like Systrix or Ahrefs to look for parent topics to build that cluster a bit more, to make the clusters a bit more thicker as well. Would that be possible as well, or is it just one data source we can use when it comes to the search queries?
I can say something on that. Like the beauty of this technique is that it shows you the similarities and differences in your data. So whatever data you put in, you will get like to see similarities and differences. So if all your stuff is about hockey, it won't all cluster in the hockey space. It will like still show you a nicely laid out projected graph. Then regarding your data, like what can you put in? If you have like data from multiple sources, it is extremely important that they all are semantically that they are all similar data. Like if you will put in talking about hockey, if you will put in one news stories thing and on the other hand a betting data set or whatever, I'm just saying whatever, you will see two very distinct clusters probably in your projection, because you have basically two different types of information, and that will become very apparent. I tried doing this also with data from the EU, how the MEPs voted, and I tried to combine that data set with stories sourced from the news, because I kind of wanted to show which news media are how oriented in the political spectrum. Well, that's almost impossible, or I couldn't make it work, because these two data sets were so different that you would have like politics here in this little cluster and then news in this completely different cluster, just because they're two completely different things and these completely different worlds, as it were. But if you have multiple data sets just on your hockey stuff in the same sort of, like, I would say, the same type of information, then you should be relatively good, and then this could be very interesting for you.
Thank you.
Thank you. I'm really curious, Anastasia, if you have anything to, like, any observations or anything to add. I'm really curious how you use embeddings in journalistic stuff.
Everything sounds about right. I think that's pretty much what everyone does when people do that. And also the model that you mentioned is also very much recommended by everyone in the industry. The embedding model, I mean.
So it's all very standard and boring.
It's not boring. So it is, but it's a good thing. It would be strange if you do something quite very weird.
Is there anything out there that is new, emerging, that you see potential in when it comes to application? Like for journalism, this is also still quite niche, I think. I don't think many people use that. So for journalism, this is already quite advanced. But I'm curious, like for you as a professional, do you see any new techniques emerge, any new exciting things happening in this space?
I don't think so. I mean, one thing you could probably have done differently is your topic vectors. They could have been more sophisticated, I guess. I mean, they can be not just based on the list of words, but be like a center of some kind of clusters or something like that.
Mm-hmm.
But that's the only thing that comes up. But in industry, I don't think there are any innovations. Everyone is focused on LLMs now and how to make them so powerful. So I assume some Claude embeddings are better somehow for some tasks. But everyone is just training, or maybe some smaller models or some task-specific embeddings from smaller models. But yeah, maybe someone, if they have a very specific task, they could fine-tune them to a certain task.
Mm-hmm.
I don't think anything completely groundbreaking is emerging right now.
I would be curious about training models. I never dabbled into that.
I mean, it is fun, but one needs a certain task for that, and yours seems to be working well enough as it is.
Yeah. I think so. Yeah.
I think the trick is here to use the general models as nicely as possible, so you don't have to train your own model. That's kind of like.
Yeah, but if you wanted to run locally, I mean, it worked for you, right? But there was a point, I think, when like sentence transformers were not good enough, but big models were like much better. Maybe at that point it made sense to fine-tune them for a task. But right now, yes, with this embeddings, it's good enough for most tasks, I think.
Okay.
If I would be doing that, I would be doing exactly the same thing.
Talking about, you say like taking the mean of for the topics, taking the mean of a couple embeddings. It's nice to have you on this line now, because for these documents I'm doing, there are certain documents that have like lots and lots of chunks. You have to really lots and lots of chunks. Do you think it's still meaningful to take the mean of those chunk embeddings and project them into this space together with other documents that are very short? I hope I make myself clear.
I mean, I think it depends on what. I think you should try, honestly, because it's hard to tell what these dimensions really represent, right? Like, if they work so well that they capture the meaning from the chunk in terms of document, they should be similar. But then, what exactly they do, no one really knows.
Mm-hmm.
Yeah,
It preserves some useful characteristics of language for us, but we don't know how exactly it happens.
that's the beauty of all these things, I would say.
Yes, it's a magic.
Thank you.
Are there any last questions, remarks? Sarah?
If we still have a moment, although it's a bit off topic maybe, but since you just talked about it, about clustering or making sense of documents in space, I was just wondering, how would you have to do the labeling for different categories there yourself, or have like expert reviews on what's what before working with the models to identify those, or how would you go about that?
I'm not completely sure yet. Like what I learned from this topic modeling here in this news thing shows me that for the document collection, it might be just less useful. Like I have this PFAS stuff, and I was thinking of like taking like a research paper and lobbying meeting, stuff like that, and then taking like a lot of words that are like related to that. I'm not sure how useful that is, and I think that something like this HDBSCAN clustering algorithm to show natural clusters in this information might be more interesting. One of the sort of like benefits of this like topic modeling with these embeddings is that we can kind of choose later to recalculate only how close everything is to these sort of anchor points. And I call them anchor points, but because they are seriously anchor points in this high-dimensional space, and all we do is look how closely related to all these anchor points these news items are, or these source documents. So I'm also thinking of maybe allowing people to choose a set of these things themselves. So this is also something that here we can say like anger, and ideally this works, and I get to see everything that is like very closely related to anger. So people are taking a different direction, speak English comments like Mr. Beast employee. He was arrested. So you can kind of like take any word and look how close other things are. So I'm also thinking of, instead of having only this search here, just allowing people to set their own topics, embed these things, and calculate over the whole set. But this news thing is made so that multiple people can play with it easily. This source documents thing is way more aimed at a team of researchers really getting down with this information. So you would make different choices there, I think. So I don't want to be the person there making a set in stone choice of what people can do or don't. Yeah.
Really cool. Thanks.
Thank you for the question. Any other observation, question? We're like at the end of the session anyway. So if you need some time to process, or you think tomorrow, oh, I have this idea or I have this question, you know where to find us. We are in the pond. The community for and by nerds in the newsroom or outside, doesn't really matter.